Example 3, still on pH. Remember what I told you that we'll continue to solve for pH until we become master of it. What is the hydrogen hydroxide ion concentration in a solution of pOH of 5.55? They ask again, what is the hydrogen ion concentration in the same solution as in A above? So if you watch very carefully, they gave pOH to be this. So what we are going to do now is to pOH, this time around not pH, equals negative logarithm to base 10 of the hydroxide ion concentration. Just substitute OH for hydrogen ion. So that will give you what you need. So we can decide to rearrange the negative logarithm to the extent of the OH ion equals pOH. It is quite understandable that they gave us the pOH to be 5.55. 5.55. Okay? We can decide to multiply both sides by negative so that this negative here will go up. So this thing becomes log of this equals minus 5.55. Don't forget the way we always do it. We are going to split minus 5.55 into 2 in order to get what we need. And if your calculator is working very fine, you understand that if you split this into 2, it will give us something like 0.45 minus 6.0. If you try it in your calculator, you get minus 5.55. So what we are going to do now is, how do we get the OH? OH ion. Remember they asked us to, what is the concentration of the OH ion? Not forget that this square bracket means concentration. So what are we going to do to get it? You are going to do anti-log of this and the anti-log of this. So that this logarithm will go up. Anti-log of 0.45 multiplied by anti-log of 6.0. Multiplied by anti-log of 6.0. So if you press your calculator very well, you can help us to press the calculator. If you press your calculator very well, you know that the anti-log of 0.45 is 2.8 approximately. This is 2.8. Check very well. Let me press again. 2.82 approximately multiplied by 10 raised to power minus 6. You can as well decide not to find the anti-log of this and just multiply by 10 raised to power 6. But because of the fact that has negative sign, you raise it up. Because if you do the anti-log of this, you are going to get zeros into 6. That is why it is 10 raised to power minus 1, 6, because of this negative sign. So this is the hydroxide ion concentration in this solution that has pOH of 5.5. That is A part of the question. Remember that they say, what is the B part of the question reads, what is the hydrogen ion concentration in the same solution? Since we have gotten the OH, they now ask us to find the H. So remember a formula that we listed. Now, did you remember this formula that we listed? That was why I listed the whole formula for us. Remember, this is square bracket. The concentration of hydrogen ion multiplied by the concentration of the hydroxide ion give you 10 raised to the minus 14. 10 raised to the minus 14. Remember, they asked us to find this one. We have gotten this one to be this. You get? Gotten this one to be this. So substituting this one, substituting for this is 2.82 times 10 raised to the power minus 6 multiplied by the concentration of the hydrogen ion gives equals to 10 raised to the power minus 14. How do we get this? Divide both sides by this. So hydrogen ion concentration becomes 10 raised to power minus 14 divided by 2.82 times 10 raised to power minus 6. That is how we are going to get the hydrogen ion concentration. And calculator will just do justice to that. To do justice to that, if you press your calculator very well, you get something like hydrogen ion concentration gives you 3 point, let me press again, 3.55 times 10 raised to power 3.55 times 10 raised to power 9 mole per dm cube. Please, the concentration of all these things, whether hydroxide or hydroxide, is mole per dm cube because we are talking about concentration. That is the B part of the question. Concentration of a hydrogen ion is this. Check it very well. That is why we exhausted all the formulas that you need here. So check again